Anong physics application ang pwede mong magamit kapag ikaw ay magpupull up katulad nitong gagawin ko? Alam mo ba yun? Kung hindi mo pa alam, panoorin mo ang video ito. Good day everyone! Welcome to Sir Fox Learning Channel. For today's video, pag-aaralan po natin ang work, power, and energy. What are the different forms of energy? How to calculate power? And what are the relationships of work done, power, and energy? Kung gusto mong malaman ang mga ito, panoorin mo ang video ito. Happy learning!
So last time, we started discussing this concept, work and potential energy under most essential learning competencies number 28 to 32, week 6. So ito, defining work as a scalar or dot product of force and displacement. Interpret the work done by a force in a dimensional as area under force versus position curve. But itong third up to fifth, hindi na natin na-tackle. Ito yung ating i-discuss this morning, relate the gravitational potential energy as a system of an object or object to the configuration of the system, and then relate the elastic potential energy of a system or object to the configuration of the system, and then explain the properties and effects of conservative forces. So, as I recall, if you have this graph and you are asked to, number one, to find the work done of the force on the particle as it moves from 6 meters to 10 meters towards x-axis. What will be the work done? So, again, in solving problem, the first thing that we should do is to determine our given. Diba? In solving problem, always determine the given. So yung given po natin must be force and the displacement, because you are looking for work. All right, Jana, what will be your force? On the graph, your force is the vertical position and your displacement is the horizontal position, right? How did we determine that the force is in the vertical position? Because of the unit measure given here. At nakalagay na dyan F sub x is equals to 0, 1, 2, 3. And for your displacement, paano mo na-determine na ito ay displacement? Nakalagay dito sa dulo, your x is measured in meters. Displacement is measured in meters. Therefore, this is your displacement. If you have number 1, you are asked to find the work done by a force on the particle as it moves from 6 meters to 10 meters, what will be the work done? So, nasaan ba yung 6 meters to 10 meters?
3 newtons po, sir.
3 newtons. And then, what will be your displacement? Ang sabi dyan, the particles moves from 6 meters to 10 meters. Therefore, Edwin, you're raising your hand a while ago. Ano yung kanyang displacement? Edwin.
Sir, di po ako sure eh. Pwede po try na lang po.
Sige lang.
Sir, 4 meters po.
4 meters. Paano mo nasabing 4 meters?
Ah, ang ginawa ko po, sir, is yung final displacement minus initial displacement po.
Sinubtract na yung final displacement minus initial displacement na 10 minus 6. Pero since may graph tayo, pwede rin po nating bilangin yung units, di ba? Pwede rin natin bilangin by units. So from 6 meters, nandito yung 6 meters hanggang 10 meters. Ilang units yan? 1, 2, 3, 4. 4 units. So, sinubtract din ni Edwin, 4 units din. So, that is 4 meters. Ay, small letter. 4 meters. Therefore, your work done by applying work is equals to force times the displacement, and then your work done is equal to, Marcos, you're raising your hand a while ago.
Sir, 12 po, sir.
Okay, by substitution, you have force is equals to 3 newtons times your displacement 4 meters. Therefore, you will get 12 newton. 1 newton meter is equals to joules. Okay? Okay, what about number 2? Find the work done by the force on the particles as it moves from 12 meters to 15 meters. What will be the work done? Ang hint po dito is to use the area of triangle. Triangle. So the area of triangle is 1/2 base times height, di ba? 1/2 base times height. So, ibig sabihin, your height dito will be your force, and the area of this is equal to 1/2 base times height. Okay? So, kung ang number 2 ninyo, you are asked to find the work done by a force on the particles as it moves from 12 meters to 15 meters, what will be the work done? So what will be your given? Ano yung force mo? Force is equals to, yes, Marinel, what will be the force? Ano yung height niya?
Sir, I think it would be 1.5 Newton po.
1.5 Newton. Kasi yung 12, yung nandito.
Yes po, nasa pagitan ng 2 at 1.
Okay. So you have 1.5 Newton for the force. For the displacement, you will get, what will be your displacement?
Sir, ano po? 3 meters po.
3 meters. Using the formula of work done, force times each displacement, will get a quantity of 1.5 newtons times the quantity of 3 meters, and then that is equal to, Kelly?
4.5 joules po.
4.5 joules. Na-multiply na natin yung base times height, di ba? And then we will divide 4 over 2. And that is equal to, Jake,
2.25 po, sir. Joules.
2.25 joules. Okay. Relate the gravitational potential energy of a system or object to the configuration of the system. And then relate the elastic potential energy of a system or object to the configuration of a system. And then explain the properties and the efficiency of conservative forces. So, ito yung may tanong ako dito. Paano nga ba makakalculate po natin yung amount ng work done in a given unit of time? Kumbaga, ito ay time pressure na, di ba? Pag sinabing per unit of time, parang sa parang sa entrance exam. Usually, ang entrance exam ay merong time limit. Kahit anong klaseng exam, merong time limit yan. So, paano makakalculate yung work done in a per unit of time? So, what will you do for you to calculate the work done? Juliana? Meron ka bang idea, Juliana?
Hindi ko po alam, sir.
Si Alex may idea. Alex, what is your idea about this?
Ay ko lang po, sir. Ano po, time taken times, rate of work.
Time taken times rate of work. Si Marcos, meron ding idea?
So, ganun din po yung sagot ko.
Time taken times rate of work. Si Marinel, meron ding idea?
I think, sir, it would be, yung joule, yung nakuha nating joule from the work and then divided by the time. So, that's the power. Kasi yung ganun pong is power na po ang tawag doon. When we measure the amount of work done per unit of time, that's power na po.
Okay. If you want to calculate the amount of work done per unit of time, ibig sabihin you are calculating for power. Okay? Power. What is power? Power is defined as the amount of work done per unit of time. Actually, tinanong ko lang ni-reverse ko lang yung definition ng power. So, power is work per unit of time. Oh, sobrang laki naman. Work done per unit of time. Okay? So, kung ang power is work done per unit of time, and then your work is equals to force times its displacement. Therefore, power can be equal to force times the displacement over force times displacement over time. Force times displacement over time. And therefore, pwede mo ring i-derive yung power as power is equals to what is D over T? What is D over T? Force times D over T is equal to distance over time or displacement over time. Kasi yung work is displacement naman. Displacement over time is Glindo. Ano yung displacement over time? Ano yun?
Is it velocity po, sir?
Okay, that is displacement over time is velocity. Therefore, you can also calculate your power as force times the velocity. Ibig sabihin, in identifying the power, you can use the following formulas if ever to whatever given in a certain problem. Ibig sabihin, depende sa given ng problem. And power is measured by watts. A 60 kilogram man. Medyo magaan, 60. Ako 75 eh. Runs up a staircase 3 meters high in 2.5 seconds. What is the power he has developed? He has developed. So, what are given? Our given here, 60 kilograms. What is 60 kilograms? 60 kilograms is, Marinel?
Mass po, sir.
Mass is 60 kilograms. O, paano yan, sir? May mass. Eh, ang formula ng power is work over time. Force times displacement. Force times velocity. Paano na kaya yan? Ano pa? What is 3 meters? 3 meters, Marcos?
Sir, ano po, yung height, sir, or height, sir?
Height or displacement. So, yung 3 meters dito is height kasi nakalagay naman dyan eh. Staircase high. 3 meters high. So, height or displacement. And then, your time is, obvious naman, 2.5 seconds. Okay. Ngayon, paano yan, sir? Ang hinahanap po natin, power that the man has developed. We are looking for its power. Pero ang given natin, mass, height, and time. Wala naman tayong formula ng power na mayroong mass. Paano natin sosolusyonan yan, Alex?
Kukuhanin po natin yung yung multiplication po ng 60 kilograms tsaka ng 9.8 meters per second squared. Parang mass times gravity po.
Kasi ang
Wala
ano po
po
kasi
tayong
dyan,
force.
'di ba, ang formula natin ng power is force ang formula ng power po natin is work over time. Work over time, 'di ba? And then yung work is Yung work is equals to force times distance. Or di kaya, yung work pwede siyang mass times acceleration due to gravity times height. Di ba yung work? So therefore, pwede nating i-substitute dito. Ito na tayo. Sa formula ng power is equals to mgh, laki naman, mgh, saan galing ulit yung mgh? Yung work done na affected by acceleration due to gravity, divided by time. So, yung mass mo is 60 kilograms, 60 kilograms times height times 9.8 meters per second squared. Oops. Times yung height niya. Ano yung height niya? 3 meters. Over yung time niya, 2.5 seconds. 2.5 S. And that is equal to, operate muna natin yung nasa taas. 60 times 9.8 times 3 meters, Jake.
1,764 po, sir.
Ilan?
1,764.
1,764 kilogram meters per second squared is times meter pa, ay magiging unit na nito is joule, di ba? Bakit? M times M, meter squared, di ba? So magiging meter squared per second squared. Eh yung 1 Newton is 1 kilogram that meters per second squared. So may matitira pang meter kaya magiging 1764 Newton meter or joules. Sabi pala ni joule ay dapat capital letters na yung unit measure niya. Divided by 2.5 seconds. And that is equal to 705.6 joules per second or watts. So here, since we cannot use directly work over time, kailangan muna natin, kumbaga ang ginawa natin dito, kinuha muna natin yung work done, di ba? Kinuha muna natin yung amount of work, which is, the amount of work is 1,764 joules by using MGH. Yun ba yung tanong mo, Marcos? So kinuha muna natin yung amount of work, kumbaga dalawang beses tayo nag-solve. We solve for work, and afterward, after getting the work done, we solve for the amount of power per unit of time. Now, in performing work done, or even exerting much power to perform a certain task, syempre, one significant factors na kailangan mo is what? For you to have that work done, for you to accomplish a work, to perform, ano yung kailangan mo? Kasi without this big factor, ay hindi mo rin ma-accomplish yung work. So usually, ikaw sa araw-araw na gumigising ka, ano yung kailangan mo para makapag-accomplish ka ng mga task? Ano yung kailangan mo? Sino may idea? Yes, Juliana.
Energy po, sir.
Ayun, energy. Kailangan mo ng energy. So, in physics, when we say energy, it is defined as the capacity to do work. Energy is the capacity to do work. Diba? Capacity to do work. So, energy is measured in terms of work done na nagagawa mo. So, we have two forms of energy. Ano ba yung forms of energy na yan? You have the Marinel?
Kinetic and potential energy po, sir.
Kinetic and potential energy. Forms of energy. Kinetic energy, which is the energy in motion, mathematically expressed as 1/2 mv squared. Kaya ba? 1/2 mv squared. Assume na lang po natin yan na exponent po yan, ha? Hindi kaya kasi sa PowerPoint. Okay, 1/2 mv squared. So, for instance, you push an object from stationary place, probably it will move, di ba? And it gains kinetic energy. Ibig sabihin, di ba, once you push an object, the gained energy is what you call as the kinetic energy for the object to move. That's why kinetic energy basically defined as the energy in motion. So it refers to the gain energy. The gain energy, it refers to the kinetic energy. All right? The change in kinetic energy while you're pushing a certain object from each stationary can be measured from the work done on the object. So yung work done yan, di ba? Usually yung work done is equals to force times the displacement. So yung gained energy, pwede rin nating ma-measure by each work done. But since the object moves an acquired velocity, since the object moving, for example, we have here and you push this box towards that position. And then once you pushes that box, it gains kinetic energy. The change in kinetic energy can be measured from its work done, which is force times the displacement. But since the object here moves and acquire a velocity from rest, it undergoes acceleration. So yung object kasi dyan, di ba, once you push, nag-acquire siya ng velocity. For example, I pushes this box, or let us say this box is 10 kilograms. 10 kilograms yan. And a force which pushes to this box speeds or moves this box at a velocity of, let us say the velocity is 50 or 40 meters per second. So what will be the kinetic energy of this box? What will be the kinetic energy of the box? So you have mass is equals to 10 kilograms. The velocity is equals to 40 meters per second. And your kinetic energy is equals to 1/2 mv squared. By substitution, you have 1/2 times times the mass 10 kilograms times each velocity 40 meters squared. So that is equal to 1/2 times 10 times 40 times 40 1,600 meters squared. Equals to 1/2 times, don't forget to indicate the unit measure, times 10 times 1,600 16,000 kilograms meters squared. Divided by 2, 1/2 times 16,000 kilogram meters squared divided by 2, 8,000. So you have 8,000 kilogram that meters per second squared is Newton, plus may isa pang meter dito. So that will be Newton meter or joules. Form of energy, general form of energy is the potential energy. Potential energy is the energy possessed by an object due to its position, or this is also known as energy at rest, mathematically expressed as the mass of an object times its acceleration due to gravity because of its position and height. So this energy is commonly known as energy at rest. There are forms of potential energy. Forms of potential energy. So what are these? What are those? You have the gravitational potential energy, which is the energy possessed by an object due to its position relative to the ground. Gravitational potential energy, the energy possesses by an object due to its position. However, this gravitational potential energy is determined by the height of an object above the Earth's center of gravity. The gravitational potential energy of an object varies directly with the mass and height of the object which is raised. And this means that the higher we place an object with respect to the ground, so yung ating reference point is the ground, the greater the potential energy. Okay? So let us have an example of this. Halimbawa, itong box ay, tapos ito yung ground. Ito yung ground. And then, you raise this box from the ground. So, you raise that box. Halimbawa, itong box ay may tali. Okay, ito ka. Inangat mo yung box. Siyempre, meron diyang sabitan. Okay? At yung mass ng box na to, sabihin natin 5 kilograms. Yung mass. And then the height, yung height natin dito, let us say this is 10 meters. So what is the potential energy? By following the formula of mass times acceleration due to gravity times height, that is equal to, your mass is 5 kilograms times the acceleration due to gravity, 9.8 meters per second squared, times the height, which is 10 meters, and you will get 5 times 9.8 times 10. It's equals to 490 joules. Okay? 490 joules. So you will notice here, the box acquires gravitational potential energy since you raise this box at a height of 10 meters. Therefore, the box acquired gravitational force. Aside from gravitational potential energy, we have also another form of potential energy, which is the chemical potential energy. This chemical potential energy is energy possessed by an atom. Energy by an atom or molecules of a substance which is released or changed into other form. So aside from this, you have also the elastic potential energy. The elastic potential energy is the energy possessed by an elastic materials, of course. Elastic nga due to its condition. by an elastic materials due to its position. So, for example, of this type of potential energy, yung ginamit ni David, slingshot, stretching a rubber, stretching a bow is an example of elastic potential energy. If a spring is compressed or stretched, you do work. Diba? Once you stretch the spring or even rubber, you do work. And the amount of work needed to compress or stretch of the spring depends on the force required per unit length. So yung amount of work, nakadepende syempre dun sa force na ginagamit mo. When the distance or length of a material increase, the elastic potential energy is negative. And the potential energy or the elastic force is negative. So the potential energy is increased. When the distance decreases, the elastic force does positive work and potential energy decreases. So the potential energy is calculated, or the elastic potential energy is calculated by potential energy of an elastic is calculated by 1/2 K times D squared. Suppose you are given with this example, a 5 centimeter rubber band is stretched to a length of 10 centimeter. What is its elastic potential energy? So in solving problem again, we need to determine the given of the problem. So our given here is you have the displacement D1 is equal to 5 cm. D sub 2 is equals to 10 cm. And you have your K. What is K? K is the elastic constant of every material. In this case, our elastic constant is of rubber. Elastic constant of rubber is 50 dynes per centimeter. 50 dynes per cm. Okay, elastic constant. So you're asked with your elastic potential energy. So what is your elastic potential energy? You have a formula of 1/2 times K D squared. KD squared. That's your formula. By substitution, at first, we need to derive first our displacement. You have two displacement. We will get our D by getting its D is equals to D sub 2 minus D sub 1, which is equal to 10 minus 5 cm is equal to 5 cm. Therefore, your EPE, elastic potential energy, is equals to 1/2 times your elastic constant of rubber is 50 dynes per cm dynes per cm times 5, your d squared is 5 cm squared. Therefore, this is 1/2 times 50 dynes per cm or centimeters times 25 centimeters squared. Centimeters squared. And that is equal to 50 times 25 times 1 divided by 2, and you will get your EPE here, or elastic potential energy, is equal to 625 Hertz. Okay? So remember, energy cannot be created nor destroyed. It is only transformed from one form to another. So, ibig sabihin, energy is always conserved. The total mechanical energy is always conserved. Potential and kinetic energy are mechanical energy. And this energy, in terms of work done on an object, is always equal, or it is always conserved. Work done on an object is equal to the change of kinetic energy plus the change of potential energy worked by an object, or work by an object, and therefore the total mechanical energy is equal to the potential energy and kinetic energy. Okay? Hopefully, itong ating lessons, week 6 of General Physics 1, ay nakatulong po sa ating mga distance learners who are taking General Physics 1. At kung bago ka sa channel ni Sir Fox at nagustuhan mo itong ating video lesson at nakatulong po sa iyo, sana po huwag niyo pong kalimutang mag-subscribe at i-hit ang notification bell para maging updated ka sa mga susunod ko pong video lesson. Happy learning, everyone. Marami pong salamat.